Recording started.
Hi everyone, we're doing a recording now to help you prepare for your first test, which is going to be on your first 4 lessons, which is lessons number 1 to 5. It's going to be on March 14th, which is going to be a week from this Wednesday. What we're going to do here is we're going to go over a number of questions that are going to be really similar to the ones that are going to be on the test, so please practice these. We're not going to go over the actual answers, but we're going to go over the solutions. So basically, if you want to complete the solutions and find out what the answers are, you can do that. But what we're going to be doing is going over the solutions. So first question here has to do with renting a house, or renting a apartment rather, I guess, or a townhouse, I guess it is. It says Kathy and Stephen are moving into a townhouse. The monthly rent is $950. Their landlord wants them to pay for both the first and the last month's rent before moving in. And the local electricity provider requires a $250 deposit to set up their service. The local natural gas provider requires a $225 deposit. So the question is asking how much will they be required to pay before they move into their townhouse. So there's a number of things there. We're just going to underline them. They're going to have to pay for the first and last month's rent before moving in. They're going to have to pay for electricity, $250, and a gas deposit of $225. So if we look at those things now, the deposit they're going to have to pay in total is 2 months' rent, electricity amount plus gas amount. So whatever the month's rent is, $950, we multiply by 2, we add on the electricity amount of $250, and then we add the gas amount of $225, and when we get a total amount for that, that's going to be the amount we're looking for. Excuse me, that's how much they have to pay before moving into their townhouse. All right, so let's go on to the next one. And again, you can add up the amounts as you go along, see what answer you get. We're getting up to tax time in the next few months, and if you talk to your parents about that, it can sometimes be a little bit of a stressful time, just trying to get your bills together and stuff like that, all your receipts, and then whether you do your taxes yourself or turn them into the accountant. It does take some organizing and thinking things through. So anyways, I thought this was kind of a cool picture. I'm not sure exactly what the tax deadline date is, but it's somewhere around sometime in April, I think. Anyways, this says calculate the property tax payment for $3,480 paid weekly, rounded to the nearest dollar. Okay, so basically what we're looking at is we've got a yearly tax amount and we want to get a weekly tax amount. So how do we find that? Weekly tax payment equals annual tax payment divided by 52, because there's 52 weeks in a year. Okay, so all we're going to do now is divide the 3480 by 52, and we'll get a weekly amount. When we go to the next question, it's a very similar question, similar tax amount, but it says we're paying it quarterly. So quarterly means 4 times a year. So quarterly tax payment equals annual tax payment, again, the 3480 divided by 4. So all you need to do for this one is divide 3480 by 4, and you'll get the quarterly amount. Now I'm just going to go over, there's different terms. We talk about quarterly, we talk about weekly. Of course, an annual tax payment is once a year. Biannual means twice a year. Quarterly, again, is 4 times a year. Monthly tax payment, we're going to divide by 12 for 12 months, and weekly tax payment, divide by 52. That covers pretty much all of them. There could be bi-weekly as well, which is 26. All right, question number 4 says the Taylor family is consulted with a financial planner to help balance their expenditures. They were presented with a guideline as shown in the graph below. So basically we've got a pie graph here, and the different pieces of the pie represent different percentages for the recommended percentage that this family spends on each of these different areas. I know that these numbers here are hard to see, so I kind of wrote them out again. I wrote them here. It says here the maximum monthly amount they could pay for housing and utilities is. Okay, so we need to find a dollar amount. Now we're given this amount, their net income is $46,200 per year. Now we're told that the housing and utilities amount is 30%. So we need to find out what 30% of $46,200 is. That will be the monthly amount they can spend on housing and utilities. So here's what the calculation looks like. Housing and utilities is equal to 30% of yearly income. Then we need to divide that amount by 12 because we're looking for a monthly amount. Okay, so 30% of yearly income is like 0.3 times the yearly income, which is $46,200. Again, 30% is like 30 divided by 100. Remember, percent always means divided by 100. So you can divide 30 by 100 on your calculator, and you'll get 0.3 as a decimal. So we multiply that by the yearly amount, and then whatever answer we get for that, we divide by 12 because we're looking for a monthly amount. It's really important that we remember that it's a monthly amount we're looking for. So we have to divide by 12. Okay, question number 5. It says, Maria and Charlie have owned their home for 1 year. A copy of their expenses spreadsheet is shown. Okay, so of course expenses are things that we pay during the month, whereas revenues are, money that's coming into us, to our house. Okay, so it says, what were the total home expenses in September? So what we need to do then is look at September and add up the 3 expenses. When we look at the categories up above them, we see that mortgage is this amount, gas is this amount, and water is this amount. So we just add those 3 numbers together and we'll get the total September cost or total September expenses. And that's all there is to it, to that one. All right, question 6. And it says, Carolyn's looking for an apartment she can rent. Of course, that's an exciting time when you're looking for your first apartment. It says her monthly income is $1,792. She wants to spend no more than 40% of her monthly budget on rent. Which apartment below is the highest rent she can afford? Okay, so what we have to do is we have to find out what 40% of her monthly income is. And again, 40% is 0.4. We multiply that by the monthly income. And so 40% of that amount is this amount here, $716.80. Now the question says, and maybe I should underline that, which apartment below is the highest rent she can afford? Okay, so we want to look at the $1,716 and see which amount is the highest amount, which amount is just a little bit lower than that, but it's got to be lower. Okay, so you can decide which of those amounts is the highest amount she can afford for an apartment. All right, question number 7, or question numéro 7. Sorry about my French. Anyways, it says Josh qualifies for a bank loan to buy a new car, as if you could buy a car for like this for $25,000, right? Anyways, we'll pretend, right? He has the option of making monthly payments of this much for 4 years, or monthly payments of this much for 5 years. So the question says, how much is he going to save by paying it off in 4 years as opposed to 5 years? So a 4-year loan is always going to cost less than a 5-year loan, right? So how much is he going to save? Well, how much does he pay each year? That's the question. That's the first thing we need to do. To find out how much he pays each year, we look at his monthly loan payment. So let's look at the situation where we have 4 years. His monthly loan payment is $59,750. We multiply that by 12 months to get how much he's going to pay in a year, times 4 years for the number of years. Okay, when we do this multiplication, this is going to tell us the total amount he's going to pay if he takes out a 4-year loan. The monthly loan payment times 12 months times the number of years. Okay, so we're going to do that calculation for the 5-year loan and for the 4-year loan. And we're going to subtract those two amounts, and that's going to tell us how much he's going to save by paying off the loan in 4 years instead of 5 years. Okay? Alrighty. So, and if you do have any questions about these as you're watching, just let me know. It's really important to practice these and make sure you know how to do these on your own. And you also might want to look at the PDF file that I sent with the recording, so that way you can look at over either by watching the recording. Well, first you want to watch the recording. After you've watched the recording, then you can look over the PDF file and practice the questions that way. All right, question number 8. It says, what is the wisest advice, if you can afford it, to help pay back a loan the quickest? So there's different ways of paying back a loan, but some of them are better than others. Now, each month you pay interest on the amount of loan you borrow, so getting a lower interest rate, of course, is going to be good, right? You want the lowest interest rate when you borrow money. The more payments you make on a loan, for instance, if you're making them bi-weekly instead of monthly, that would be good, right? The more payments, the better. However, in this question, it says making monthly payments instead of bi-weekly. Well, that's kind of the opposite direction, right? That's not what we want. We want bi-weekly instead of monthly. Okay, but that is a way to pay your loans down, paying them more often. And the more you can pay off on the principal, in other words, at the very beginning, the first amount that you take out in the beginning, whether it's a loan or an investment, that's called the principal. And if you can pay a larger amount of principal, that's actually the fastest way to pay your loan down, because there's less interest it's going to accumulate, because you get interest on your interest, right? And you don't want to pay interest on your interest when you're paying a loan. Okay, so that's the best way to pay off your loan. Pay off the interest as much as you can at the very beginning. But each one of these are good ways of paying off your loan. That's just the best way. Okay? So look at the answers here and see which one looks like the best way to pay off your loan. Okay, it says, which of the following would not help to pay down a mortgage faster? Okay? So we're looking for a bad way to pay down your mortgage. Again, a mortgage is just a special type of loan. So all the different principles that we looked at in question 8 apply here as well. Okay, so increasing the deposit means less money is being loaned. Okay, so in the beginning you put down a deposit, and then the rest is the money that's loaned. So the more money you put down as a deposit, the smaller your principal is going to be, right? Okay, so increasing your deposit is good. The deposit you put on your house at the very beginning, something like, $20,000 or $50,000, whatever it is, means less total interest is going to be paid. More frequent payments on your mortgage. Again, weekly instead of monthly. Again, that means your mortgage is either going to be paid off more quickly on your house, or it could mean that you're going to have less total interest being paid. Both are good. A larger monthly loan payment. So if you're paying off more, say you're paying $500 a month instead of paying $400 a month, that's another good way to pay off your mortgage more quickly. Now, decreasing the interest rate is good. If you can find a lower interest rate on your mortgage, that's good. But if it was a higher interest rate, that would be a bad thing, right? Okay? So looking at all the different information here, you can compare that to the different choices here, and you'll see which one of these is a bad way to pay your mortgage down. Okay, so some of these are good ways, and we want to find which one is not a helpful way. It's not going to help us to pay down our mortgage more quickly. Okay, so again, the blue information here will help you decide which is not a good way of paying down your mortgage. All right, question number 10. Which of the following would not help speed the growth rate of an investment? Okay, so this time you're not paying down a loan, you're trying to make an investment. Okay, so which is not helpful? All right, so this is kind of the opposite from the last questions. So again, when we're looking at loans or mortgages, we want a low interest rate. We want a small amount of principal that we're borrowing. in the beginning, and we want the interest to be calculated less often for us. But we do want to pay down the mortgage more quickly. Okay, but with an investment as compared to a loan or a mortgage, with an investment we want a high interest rate. It's going to help us make more money. We want a large amount of principal invested in the beginning. I put amount borrowed. I should have put amount invested because we're talking about an investment here. And we want the interest to be calculated as often as possible on our investment, so weekly rather than monthly. Okay, so with that in mind, think about some of these things are going to be good for helping us to speed up our investment, to get more of an investment, more interest earned, but some are going to be bad, and we're looking for the one that's not going to help us with our investment, okay? Because it says which will not help speed the growth of an investment. Okay, so you can decide which one that's going to be. Okay, awesome. Okay, so any answer that's the opposite of one of the ones that we said would increase an investment is going to be one of the ones we're looking for here. Question 11. It says, which of the following formulas could be used to model the value of an initial investment of $800 that earns simple interest at a rate of 6% per year? Let's kind of review what simple interest is all about. Okay, with simple interest, we don't make interest on our interest. We simply make the same amount of interest each period, each compounding period. So if we put $100 in the beginning, we just keep making $50. It's not like we get $50 added to the 100 and then we get interest on that 150. That's not the way it works. Or like we don't get a certain percentage. If it's 50% in the beginning, you know, we're getting 50% of that beginning amount each time. It's not like we add $50 to the 100 and then get 50% or half of that. That's not the way it works. It's always 50% of the original amount we started with. Okay, so the interest amount we make, the amount of interest we make overall, when we're talking about simple interest, also known as the return on investment, is equal to the principal, that's the amount we started with, times the interest rate, that's always got to be as a decimal, not as a percent, times the number of interest periods. So interest earned equals P times R times N, or I equals PRN. Okay? Always remember, take the percent, 50%, and make it into a decimal. All right. So, since this is a simple interest formula, if we're looking at the value of an investment after a number of years, that's how much it is with how much you started with plus the amount of interest earned. So the value of an investment is equal to the principal, how much you started with, plus the interest earned. Okay, so if we're actually using the numbers in this question, our principal is $800. Our interest earned is $800 times the interest rate, which was 6%. We make it into a decimal, times the number of compounding periods. We just call it N. Okay, so another way of saying what we said right here, if we say 0.06 times N, we just call that 0.06N. So we have 800 times 0.06N. Okay, so we have 800 that we started with, plus the 800 times the interest percentage. Okay, so now we're just going to rewrite this here in a different way. We rewrite it as this here. You can see it's rewritten as that because if you multiply 800 times 1, that gives us the 800. 800 times 0.06N gives us this here. Okay? There's a reason we rewrote it like this, because this is basically the simple interest formula. Okay? This formula tells us how much we have overall by the time we've put in our interest. So how much do we have on our investment? Remember, this formula here was just dealing with the interest earned. This formula here is telling us how much we have, which includes the amount we started with and the interest earned. So this is the value of our investment. Okay, so this is, in other words, the principal plus the interest earned. That's all taken into account in this here formula. Okay, so now we'll look at what happens to that on the next page. Okay, I'm sorry. What we're actually doing at this point. Okay, so I just wanted to show you that we had the principal plus the interest earned, and we came up with this formula. Now what we need to do is we need to choose one of these answers. Okay, so one of these answers here is basically the same thing that we've just come up with. Okay, so one of these answers is an answer that represents the value of the investment after a number of years. Okay, maybe I should just read the question again. So we had an initial investment of $800 and we earned 6%, and it said which of the following formulas could be used to model the value of an investment. Okay, so that's what we're after, the value of the investment after a certain number of years. That's that there. And one of the answers looks just like that. Okay, but I was just trying to show you where that came from. Okay, let's go on to compounding interest. So remember, the compounding interest is interest on your interest. So it builds a lot more quickly than simple interest does, which is awesome. You want compound interest when you're making any kind of investment of your money. And Albert Einstein, who of course talked about stuff like nuclear physics and exploding the atom and stuff like that, he said that the most powerful force in the universe is compound interest. So he's not saying it's the atom, he's saying it's compound interest. Kind of an interesting spin on things there. Okay, so let's look at something that kind of helps us see what compound interest is all about. Here, you start with $100, you make 50% of that $100, you've got $150 by the end of the year. And now you make interest on your interest. So you're making 50% of that $150. Now you've got $225. Wow, you started with $100, you've already got $225. Next year you make another 50%. Now you're up to $337.50. Again, compound interest builds quickly. Let's just look at the first year here. At the beginning, your loan is $100, and then the interest earned is going to be $100 times 50%, which is the same as $150, right? Now, we can rewrite the 100 as 100 times 1. We can rewrite 100 times 50% as 100 times 0.5. There's a reason we did it that way. Because now what we can do is we can rewrite this part in red as 100 times 1 plus 0.5. See, the reason that works is 100 times 1 is like this here, and 100 times 0.5 is like this here. So the way we've written it here, this is basically the compound interest formula. Again, you have the principal, the amount you started with, outside the brackets. Inside the brackets, you have 1 plus the interest rate. Okay? But that shows you how much you've made after the first year. Because 1.5, 1 plus 0.5 is 1.5. So we multiply the 100 we start with times 1.5, and that gives us the amount we're going to have after the first year. Now, let's see what we're going to do with that, 100 times 1.5. Well, if we want to look at how much we've made after the 3 years, like you see in the picture here, you're multiplying 100 times 1.5, that's year 1, right? That gives you the 150. Then you're multiplying this 150 here times 1.5. That's what you're going to get in the second year. And then you're going to multiply what you've got so far times 1.5. Okay? So another way of saying 1.5 times 1.5 times 1.5 is 1.5 to the exponent 3. So again, this here is the formula that shows us how much we're going to have in investment or a loan after the 3 years. Okay? But I'm just kind of showing you where that formula comes from. Earlier, we saw the same kind of formula written this way, 100 times 1.5, 1 plus 0.5 to the 3. And that's the way that the compound interest is usually, the formula is usually written as. Okay? Because what it helps you do is it helps you to just plug in your interest value, some decimal, like if you make 10% a year, you write 0.1 for the interest rate. Okay? Again, P is the principal, N is the number of compounding periods. And so after we've plugged everything in and done the math, we get A, which is the total amount of our investment. All right. So, now most of the time when you're doing compounding, you're not getting interest just once a year. A lot of times you're getting it once a month. So because of that, we rewrite this formula in this way. And you can see what we've done with the interest rate is we divide this interest amount by the number of compounding periods. So let's say we had 10% a year. Or let's say it was 12% a year. If we got 12% a year, if we compounded our interest monthly, then N is 12, because it stands for the compounding periods, right? So instead of having 0.12 for 12%, we're going to divide 0.12 by 12, which is going to be 0.01. Okay? So that's what you would do. And then you're going to raise it to this amount here. And we'll see how this formula works later on. But it's just important to remember that we need to divide the interest amount by the number of compounding periods when we compound more than one time in a year. Okay, let's look at how this applies to this question here. Excuse me. It says if $5,000 is invested today at a rate of 8.5% per annum, that means per year, compounded annually, then the value of the investment at the end of 3 years. Okay, so we're looking at the value of the investment. And remember, the value of the investment is always the A. You know, when you're saying A equals this much for the compound interest formula, that's what we're looking for. A stands for the value of the investment. So again, remember, we always put in P is the principal. That's how much is invested or borrowed. That always goes outside the brackets. That's $5,000. It's invested today. The interest rate, 8.5%. We divide that by 100, get 0.085. And since we're only compounding once a year, and it's for 3 years, we raise it to the exponent 3. All right, now we add the 1 plus the 0.085 to get 1.85. And now what we need to do to be able to do the math and find out how much this equals, we need to do these steps below on our calculator. So we put in 1.85. Next, we press Y to the N. Most calculators will have that. Let me know if you have something different. I'll help you figure out what it is. Then press equal, and you should get some amount. Okay? And so this amount that you've calculated is just this part here. Now we need to multiply that by the 5,000, and we'll get our answer. Okay? Let me know if you need any help with that and have any questions at all. Okay, question number 13. Kind of applying the same ideas here. It says, what is the amount of money that $1,500 would be worth if it was invested for 6.5 years at 5.2%, and this time it's compounded semi-annually? Okay, so we're going to have to use that special formula. We're going to have to divide the interest rate by 2 because it's semi-annually. So, as with all these questions, any kind of math question you're doing, it's always good to write the information you're given. Your principal is $1,500. Your interest rate is 0.052, but I put in brackets, it's semi-annual, so we're going to divide by 2 in our formula. The number of compounding periods, well, N is 1, right? Okay, sorry. N actually stands for, in this situation, N actually stands for, yes, the number of years. Okay? N is the number of years, so we should have written 6.5 here. But we're going to multiply by 2 because we're compounding semi-annually. So sorry, I should have written N is 6.5. Okay, so now that we know all the variables, how much they're worth, we plug them into the formula. So A equals P. P we know is 1,500. And we know the interest rate is 5.2%. We divide 5.2 by 100, we get 0.052. Since we're compounding semi-annually, we divide by 2. Okay, so we get this percent here, this decimal here, I should say. Okay, and now we had 6.5% a year. Sorry, not 6.5% a year. What I mean to say is we have 6.5 years that we're doing the compounding for, but because we're doing it twice a year, we need to multiply by 2. Okay, so we have 13 compounding periods in all, and that's what this stands for, the exponent here. Okay? So if you have any questions about how this works, how you divide this interest by how many times you do the interest a year, which is 2, and how you do this here, let me know. Okay, so basically what we're going to do on our calculator is we add 1 plus 0.026. We're going to get 1.026. And again, we're going to take that amount, press y to the n, then press 13, press equals, and multiply that by 1,500. And that's going to be our answer. So again, practice all these and make sure you can do them all on your own before the test. And the questions on the test are going to be very similar. Alrighty. So question 14. It says, which of the following formulas could be used to model the value of an initial investment of $7,000 that earns compound interest at a rate of 4.5% per year? Okay. So we know this is compound interest. So we're going to use the compound interest formula, and I will give you the formulas for compound interest and simple interest for your test. I'll give you on the formula sheet. So we're going to have to pick this out from the formula sheet. Okay? We need to remember what each of the parts means. So basically what we need to do is we need to figure out what's our P, what's the principal invested? Well, that's 7,000. Okay, so instead of P, we're going to put 7,000. Now instead of R, which is 4.5%, we're going to divide that by 100 and get 0.045. So that's going to go there. And N is going to be, we don't know how many years, so we just put N. So when you put 1,500, or sorry, that's the last question, 7,000 here, and you put 0.045 here, see which formula it's going to give you that corresponds with one of those answers. Okay? So basically, each of these questions is just asking the question I was asking. You know, what's the principal here? Well, that's 7,000, so that's what we put in here. Okay, so these questions are just helping you know how to put the numbers in this formula to find the right answer. Okay, we're getting close, guys. Next question is a fairly quick one, I think. It's a graph showing us what's happening in an investment. It says, using the following, using the information provided, how long does it take to have an investment of $1,000 grow to $5,000? Okay, so in the very beginning, when time is 0, you've already got 1,000. You want to know how long it takes. So this is time here. That's what we need to find. How long it takes till it grows to 5,000. Well, to find how long it takes, go from 5,000 to the graph. And that's going to tell you how long it takes. So you can see that it's less than 15 years, but it's fairly close to 15 years. So you can kind of estimate how many years that is based on, you know, this is going to be about 7.5. You can figure out about how many years that's going to be and see which answer you think it is. Okay? But that's what you need to do. Okay. So the next question is talking about a table of a GIC, which is a guaranteed investment certificate, special type of investment. We can see here we start with an opening balance. We have an interest rate, so we make an interest earned based on that interest rate, and then we have a closing balance. Okay, so basically we have an opening balance, we add the amount of interest, and that will give us our closing balance. That's all there is to it, really. So I just kind of wrote that in words. The amount you have at the end of the month, known as the closing balance, is equal to the amount you started with at the beginning of the month, the opening balance, plus the amount of interest earned in a month. Interest earned. Okay? So closing balance is equal to opening balance plus interest earned. Now, when you look at your answers, they're basically saying the same thing that I just said in words. Closing balance is equal to opening balance plus interest earned, except they're giving you that in short form. Okay? So you can decide which one of those you think is the right answer. And once you look at it, just make sure it makes sense again, looking at what's happening in this chart. Closing balance is equal to opening balance plus interest earned. 515 is equal to 500 plus 15. Okay. So, question 17, kind of similar in some ways. Question 17 says, Joe and Mariana purchased a house 5 years ago with a mortgage of 6% per year, compounded monthly. They make monthly payments of $1,500. In an effort to see how their money is being spent, they create a spreadsheet, shown below. And it says, which formula could be used to determine the value in cell F1? Okay, so we're looking for cell F1. So we want to figure out what formula you would put in your spreadsheet to find that amount. Okay, so how are you going to find the new balance? Well, let's see what's happening here. You start with the balance, current balance. You added a certain amount of interest. That gives you your balance with interest. Okay, so your balance has already been, your interest has already been added to your balance. Okay? Then, after you've added your interest, you make a payment, and that gives you your new balance. So this payment is subtracted from this balance with interest to get your new balance. Okay? So what we would need to do is find a formula that shows that new balance is equal to balance with interest minus the payment. Okay? So which one of these do you think would be a correct formula that we would put in F1 to show that new balance is equal to balance with interest minus payment? Okay, so new balance that's going to be in F1 is equal to balance with interest. Think about what cell number that is, minus the payment. Think about what cell that is, and that will help you figure out the formula. Okay, next question is talking about buying a stereo. This one looks pretty fancy. It says Duncan bought a stereo system for $1,290. He put 15% down and agreed to pay the remaining balance owing by paying 12 monthly installments of $110 each. In total, how much did it cost? Okay, so even though it's a $1,200 stereo, it's going to cost more than $1,200, right? So let's figure this out. He's going to put down his down payment. How much is he putting down? 15% of $1,290. How do we figure that out? Well, we can't multiply 15% times it, but we can multiply 0.15 times 1,290. And we can do that math for that part there to find out the down payment. Okay, so again, remember 15% is 15 over 100, and that's that as a decimal. Okay, so we figured out what the down payment is. How about the balance owing? Once he's put down this down payment, how much is he going to owe? Well, it says he's going to pay 12 monthly payments of 110 each. Okay, so we're going to multiply 110 times 12. That's going to be the balance owing. So we're going to add this amount that we get for balance owing plus the down payment amount That's going to be the total cost of the stereo. All right. So again, try this one out and see if you're able to figure it out on your own. And we're down to the last one. Okay, for this one here, I put in green. Please note the balance at the beginning, this amount here, should be $1,418.64. The 1 got over there. Okay, the 1 should be here. Okay? So what we need to do with this problem, it asks us what's the final balance after the February 15th cash withdrawal. Okay, so we're starting with this amount at the beginning of the month. Some other things are happening. We're taking money out here, putting money in here, taking money out again. And then how much are we going to end up having after we've taken money out and put money in? Well, the final balance is going to be the opening balance you started with, $1,418.64, plus the money added during the month, this much, minus the money subtracted, each of these subtractions. Okay? So the final balance is equal to the opening balance plus all the deposits, we only have 1, minus all the withdrawals. So we have to subtract off all of those. Okay? So we take our opening balance of this much, we add this deposit, and we subtract these withdrawals, and that's going to give us our final balance. All right. Great stuff. Thanks for watching. Please practice these questions. Again, the questions on the test will be similar. And if you practice these really hard, you should do well. If you have any questions at all, please give me a shout. Keep up the hard work, guys, and have an awesome day. Bye for now.